Here we have a function y equals x squared minus 6x plus 8. And first of all, I want to factorize this. So I'm going to write this in factor form. When we express the function in this way, we can determine the points at which the line or the graph crosses the x-axis by solving this equation for when y equals 0. Y equals 0 being the x-axis. Let's do that now. Solving this gives us these 2 points of intersection with the x-axis. Here we have 2 and here we have 4. Now we're going to look at completing the square of the same function. Here, written in completed squared form, we have the same function. What it allows us to do is see the minimum value of this function, and that is where this graph is at its lowest point, which I'll mark on with an X. Now we can see in this form that the lowest value you're ever going to get by squaring a number is 0, and that's from 0 squared. And if we let this equal 0, then we end up with y equals minus 1. So this point has a y value of minus 1. What's the corresponding value of x that makes this y value minus 1? Well, we need to solve the equation x minus 3 equals 0. That tells us that x equals 3. So this point here is 3, negative 1. So factorizing can lead us to find the points of intersection with the x-axis, if there are any, and completing the square allows us to find a maximum, or in this case, a minimum value of the function. So how do you actually complete the square, and what does it mean? Well, let's consider x squared plus 6x plus 9. I've drawn this little square here. And if we say that one of these lengths is x, then so is another length down the side there. And the area of this square is x squared. I'm going to continue to add pieces to this to hopefully form another square. Along the side here, I'm going to add a length of 3. You'll see why in a moment. Now I have this shape. If this length here is 3, then the area of this rectangle is the product of 3 and x, which is 3x. And the product of this rectangle here with the same length there of 3 is 3 and x, the product of those, and that gives 3x. Now, if I want to complete this square, if I want to make this shape a square, I need to fill in this bit here. Let's do that now. Now we have a completed square. This length is x plus 3, and this length is x plus 3. What's the area of this, though? This is the product of 3 and 3, which is 9. So we can see here that x squared plus 3x plus 9 gives us a completed square. Now this could be expressed as the product of x plus 3 and x plus 3, which can be written as the square of x plus 3. Here we have a slightly different expression. Instead of ending in plus 9, it ends in plus 8. But we can complete the square as follows. We halve the coefficient of 6, which is where our 3 came from a minute ago. And we write that here. Now if we expand this, we would have x squared plus 6x plus 9. But our expression is x squared plus 6x plus 8. So here we should have a minus 1. Let's check this now. The square of x plus 3 is x squared plus 6x plus 9. but we need to take away 1 so that we get what we started with, x squared plus 6x plus 8. And what we're trying to do is find the difference between our expression and what we get with a completed squared form. So the difference between 8 and 9. We want 8, but we get 9 when we use this square here. So we have to subtract 1. And because it's always the difference, we can do this. We can work out the square, which is 9, and take that away from what we have. And that means we're always finding the difference. Here are some more examples of expressions that you might come across. If we have a negative x squared, then we must first take minus 1 out as a factor to express this in completed squared form. Once we've done this, we can then complete the square on what's inside our brackets. And then at the end, we must remember to multiply each term by negative 1. Here we have our completed squared form. In this second example, the coefficient of x squared isn't 1, so we have to do something about it. We need to take 4 out as a factor. Now notice that 4 is a common factor of the first 2 terms, so we can do it like this. I've taken 4 out as a factor of the first 2 terms, and I'm going to complete the square of what's inside the brackets. Now I need to multiply 4 by each term inside the brackets. Here's the answer in completed squared form. One further question you might get asked is, if the coefficient of x squared is negative, what is the maximum value of this quadratic? And here we can see that the maximum value of this is 4. And this happens when the square is equal to 0. In other words, x minus 1 equals 0, so therefore x must be 1 at that point. As a graph, we would have an N shape because of the negative coefficient of x squared, and the maximum value would be at the point 1 for x and 4 for y. In this one, we might get asked what is the minimum value, and it's minimum because we get a U shape, and the minimum value is negative 5. And that is when the square equals 0. And in this case, x is equal to minus 1. And x is equal to minus 1, the square is 0, giving us the minimum value of negative 5. As a graph, we'd get a U shape, and the minimum point would be negative 1 for x, and the corresponding y value would be negative 5.